Good morning, all of you. So, as we know that in our today's class, we are going to study the next concept is Kepler's laws of planetary motion. So, if you'll see here, in the 16th century, an astronomer named called as what is that? Johannes Kepler. He has been established three laws which will govern the motion of what, guys? Motion of planet around the sun. Motion of planets around the sun. And these three laws only we should call as Kepler's laws of planetary motion. What we should call? Kepler's laws of planetary motion. Understand? So what is Kepler's laws of planetary motion? Which will govern means which will say the properties of governs the motion of planets. Motion of planets around the water, around the sun. Governs means which will conclude the characteristics. That is what you have to remember it. Now, let us see. That is why these three laws, how many laws he has been given? He has been established three laws. These three laws only is called as what? Kepler's laws of planetary motion. Understand? So now, these Kepler's laws of planetary motion, also it is applicable to the same laws, also describes the motion of satellites, understanding, like moon, around the planets. Understand, Ra? Motion of the planets, motion of the satellites also describes motion of
satellites around the planets.
Satellites around the planets. So that is what we should call as. What we should call, guys? Kepler's laws of planetary
motion.
Good morning. Anya Samya not at the end. One more boy also who is wrong. Are Maitreyan, what happened? Call him. Sai also not there. That is. So also describes the motion of the satellites around the water, around the planet. So now, Kepler's laws of planetary motion. Understanding, he has been given how many laws, guys? Three laws. Now, this one. Third one is a little bit complicated and it is a little bit difficult. So if you'll understand that, that is what Newton's inverse square law. What we should call? Newton's inverse
square law.
Has been guessed Newton's inverse square law with the help of Kepler's third law only. So that is also, if you have time permits, we will discuss that too. If not, we will see. Now I hope meeting almost all the fellows are joined. I think the Tamil Selvan also. Good morning, Tamil Selvan. Good morning, Tamil Selvan. Hello. So now let us see what it is and why we should study, etc., etc. We'll see. Now first, all of you keep heading. What is the first law? Kepler's first law. What is that first heading? Kepler's first law. Kepler's first law. Keep heading. Kepler's first law. So now, observe very carefully, guys. As we know that it is discussing about what, Elmokil? It is discussing about the what? Sun and the planets. Is it yes or no?
Yes, sir.
Yes or no?
Sir.
Very simple, Ra. Kepler's first law will says that, let us imagine, as we know that they are revolving around a circular path or some elliptical path. Correct or not? So now,
yes, sir.
The planets move in the elliptical orbits around the sun with the sun at the one of the understanding. So for example, what this Kepler's first law will say means in mathematics, you know, focus. What do you mean by focus, guys? Somewhere F we used to call it as. Is it yes or no? So focus we can say. So now mathematics you can take focus. So let us consider here two focus. How many focus, Ra? Two focus I am considering. So let me imagine this is F1 and this is what? F2. So
F2.
Plural form of focus. The plural form of focus is called as foci. What we should call, Ra? What we should call? Foci. Understand? Shruti, Laksha? What we should call? Foci we can say. Everybody respond. So focus. What is the plural form of focus? Foci. Foci is the plural form of focus. Now observe very carefully. Now as we know, what is the shape of them, Ra? What is the shape of them? The path shape is called as what? elliptical path.
Elliptical path.
Elliptical path.
Let me draw the elliptical path now here. Try to understand very carefully, guys. I am trying to draw the elliptical path. This is what we should call it as elliptical path. Will you understand? Yes, Ra?
Yes, sir.
No, all of you understand. See, I am trying to make everything because for your better understanding only. So I am trying to make elliptical path. Is it yes or no, Ra? Please understand. Now, let us imagine here we have a two focus. How many focus, Ra? Two focus.
Two focus.
This is one focus F1, and this is the another focus. What is this called as F2? Okay, guys. Now, what Kepler's law, first law will say? Listen very carefully. Very simple, Ra. So, what Kepler's first law will say? Laksha, if you're not understanding, you ask me. Maitrayan also. If any doubt me, so ask me. So, totally, how many focus we have? Two focus. What is the plural?
Focus.
What is the plural focus? Foci. So, Kepler's first law will says that planets move in elliptical orbits. Is it yes or no, guys? Elliptical orbits. Understand? Elliptical orbits around the sun with the sun at any one of the two foci. Sun is present at where? Sun is present at any one of the foci. Any one of the foci of the elliptical orbit. Understand, guys? So, planets are revolving around the sun. What is that, guys? Planets are revolving around the sun. Let us take now. I will try to draw. So try to understand very carefully. So planets are revolving around the sun. Planets are revolving around the sun, and sun is at what, guys? Sun is at any one of the focus. What is that? Sun is at any one of the focus. He is maybe at F1 or he is maybe at F2. We don't know. Understand, guys? Let me imagine he is at F1 only. Understand, Ra? Everybody respond me.
Yes, sir.
So what is the Kepler's first law? As we know, planets are revolving around the what? Planets are revolving around the sun. Isn't it? So sun, and the sun is present at any one of the focus. So how many focus we have? Elliptical path. How many focus we have? Two focus we have. Understand, guys? Two focus we have. So any one of the focus, sun may be present at here or may be present at what, guys? Present at here. We don't know. Do you understand, Ra? Elmokil? What I'm saying? So, sun may be present at, this is what I can say, what we should call this one, sun. Understand? So, sun may be present at either F1 or F2, and planets are revolving around what? Planets are revolving around the sun. So, this is what we should call it as Kepler's first law. So, Kepler's first law will say, what it will say is, everybody should say, what is that? Planets move in a elliptical orbits. Planets move in a elliptical orbit around the sun with sun at one of the two foci, either here or here. Sun is at one of the two foci, and planets are revolving in what? Which path? Elliptical path. Elliptical path. This is what we should call it as. What we should call Kepler's first law of understanding. Kepler's first law, planetary motion. I'm trying to draw the diagram also. Why? Because for your better understanding. I hope you all understand very clearly. Any doubt in this? Ask me. Okay, guys. So, this is called as elliptical orbit. What we should call? Elliptical orbit. Elliptical orbit. So, what is Kepler's first law? Blindly, you should remember. Whenever they are asking Kepler's first law, mind you have to remember this picture. So, as we know, first, what is the path? Which path it is? Elliptical path. How many focus we have? Two foci.
Two focus.
So, sun is present at where? Sun is present at where? Any focus. Any focus, not at F1. I am saying here we are taking as F1. Understand, Tamil Selvan? I am taking as F1. It may be present at where? It may be present at F2 also. Understand, Jayvarsini, what I am saying? Laksha, it may be present at F1 or F2, and the planets are revolving around the sun in which path? Elliptical orbit. This is what we should call it as Kepler's first law. So please, all of you write Kepler's first law. Kepler's first law. The planets move in elliptical orbits. The planets move in elliptical orbits The planets move in elliptical orbits around the sun. Around the sun. Mavanish, are you understand? Around the sun. Respond me, Alana, you also. With the sun at one of the two foci, with the sun at one of the foci. What is that, guys? One of the foci of the elliptical orbit of the one of the foci of the elliptical orbit. Understand, guys? Elliptical orbit. This is what we should call it as. What we should call Ra? Kepler's
first law of planetary motion.
Planetary motion. Kepler's first law, planetary motion. So if you'll observe here the planet around the sun is in which shape, Ra? Ellipse. What is that shape called as? Ellipse. Or oval shaped we can call it. This shape is called as ellipse. That is why it is called as elliptical orbit. What we should call? Elliptical orbit. Understand? Or else we can say it is oval shaped. Or what we should call? Oval shaped.
Oval shaped.
Mathematics, ellipse we can say. This is the name of this shape. All of you should remember. Like egg it will be there. Ellipse we can say. Understand, guys? That is okay.
Yes, sir.
This elliptical path having how many focus? Two focus. That is why that is called as has two foci. Two foci. And sun is at what, guys? Sun is at
F1 or F2, sir.
any one of the foci at elliptical path. Understand, Ra? And planet P. Planet P is moving around what? Moving around the
Elliptical orbit.
elliptical orbit, moving around the sun in elliptical orbit. So let us imagine sun is S and planet is what, guys? Planet is P. That's all. So P is revolving around the sun in an elliptical orbit. This is what Kepler's first law. Please draw this diagram also. Are you understand? I hope everybody understand Kepler's first law. Alana,
Sir, 1 second, scroll down,
Yes,
sir.
sir.
Arun, Laksha, respond me. Yeah, I will scroll down.
Sir,
Please respond me. If you have doubt, you have to ask me. Very, very important draw, because without this you people cannot make. That is the reason I am saying. Okay. And again I want to draw one more time like, so let us draw again. We have to make second law. So once it is completed, what is the second law, guys? What is second law? Kepler's second law. Kepler's second law of planetary motion. Darun, are you understand first law, Darun? If your school will ask also, you are able to say. Will you able to say, Mavanish? Everybody? Tamil Selvan, can you able to understand?
Yes, sir.
Now, again, Kepler's second law also. Again, you have to take same thing. First law. From first law only we will derive the second law. Very example. Observe very carefully. Now, as we know, sun when the planets are revolving around the sun, sometimes they will come close to the sun and sometimes they will go far from the sun. Is it yes, guys? Do you remember that? Because
Yes,
this
sir.
is elliptical shape.
sir.
Elliptical shape, so that the sun is on it is not a spherical shape. Spherical shape means always planet is in a same distance. Is it yes or no? But it is
Sir.
elliptical shape. Sometimes the sun will come very close to the planet, means planets will come close to the sun, and sometimes they are very far from the sun. Is it yes or no, guys? You have to
Sir.
respond me. Yes, that is. So now let us imagine. Now sun is at somewhere at one focus. Now let me take first. Everybody draw this one till here. You draw. Ask me any doubt. So this is the sun. What we should call this one? Sun.
Sun.
Sir.
Sun is at one of the foci. What is that foci called as? This one is F1 and
F1.
somewhere at what exactly? F2. Okay, guys. So now sun is at one of the focus. Any doubt till here? Any
No,
doubt
sir.
till here? Please.
Sir.
Clear? Bhavanish? Now,
Yes, sir.
observe very carefully, guys. I am trying to draw now something. Now, sun is, let me imagine. So when the planet is coming here, is it close to the sun or far from the sun? Here, when it will comes to here. For example,
Close to the sun, sir.
Close to the sun, sir.
planet is here. After certain days, planet will come here. Is it yes or no? For example, Earth only will take. Is it
Sir.
Sir.
now, after certain days, planet is here and planet is here. Now you tell me, in which situations planet is very close to Earth very close to the sun, and which situation is planet is very far from the sun? Very far from the
Sir,
sun.
when the planet comes to sun,
Planet
it is
near the
close
sun
to
is
the sun,
very
sir.
close, sir.
When the planet comes to focus to
It is
the
A
planet is too
and
far,
this
sir.
is A dash and B dash. Now you tell me. So in which situation it is
Sir,
very
AB is
Sir,
closer.
AB.
AB is closer, sir, and A1, B1 is far
and
from.
A dash and B dash is far away. Is it yes or no? Yes or no?
Yes,
Sir.
sir.
Yes,
sir.
let this is A dash. Will come here. Next will go correct because it is coming like this. So this is called as B dash. Now observe very carefully. Let me take a certain time period. For example, what is planetary? Kepler's second law will says that each planet revolve around the sun in such a way that the line joining the planet, understanding around the sun in an elliptical orbit. Observe very carefully, guys. So sometimes sun will come closer to the planets will come closer to the sun. Sometimes planet will be very far from the sun. Is it yes or no, guys?
Yes, sir.
Now observe very carefully. If you'll observe very carefully here, let me take the planet is taking from traveling from A to B. Let me take it is 5 days. How many days, guys? 5
5
days.
days.
Okay. Let time period T equals to travel from which position to which position? From A to B. Understand that? 5 days. Now planets. So this is planet. So it is taking how many days from traveling from A to B? 5 days.
5 days.
Here, once it will far from the sun. Here also I am taking the same equal interval of time. How many? What is the equal interval of time? 5
days.
Understand? So definitely it will travel some distance. Is it yes or no?
Yes,
Sir.
Now, observe very carefully. When the planets are very close to the sun, they will travel much faster because force of attraction is much more. Understand, guys? Force of attraction is
Sir.
much more.
Much
When the
more.
planets are very far from the sun, then force of attraction is what? Less. So they will
less.
travel slowly. Okay, guys?
Yes, sir.
Sir.
Now observe very carefully. I am taking a time period. How much, Jayvarshini? How much I am taking time period?
5 days.
5 days. Now 5 days when the planet is close to the sun, it has been traveled from A to B. Understanding? When it is close to the sun, so that it will cover certain distance. Is it yes, guys? Please
Yes,
tell.
sir.
Sir.
So now let's calculate that area. Whatever the area it has been covered when it is close to the sun. When it is close to the sun. So let me imagine this is what the area it has been calculated. It has been covered in this time period. Is it okay, guys?
Yes, sir.
Okay, guys. So now observe very carefully. This is what the area. So now all of you should remember this is what the area. 1 minute. Okay, guys, this is what the area. Now, the area covered in this region, let me imagine, the area covered in this region is A1. What is that, guys? A1.
A1.
A1. Understanding, Ra? Now, when it is far from the sun, planet is far from the sun, for the same time period, it will cover some other distance. Is it yes or no, guys?
Yes, sir.
Observe very carefully. If you will calculate in that time period, if you will calculate the area between the 2 points, area between
That 2 points.
understand, guys? Area between that 2 points. If you will observe very carefully, so observe very carefully here. Area between that 2 points. So now you tell me which area looks greater? Which area looks greater?
Sir, AB.
Which one?
Not A dash B dash.
Area. Wait. Right, I understood. You guys are not. This is A1 and this area is A2. Now you tell me which area looks greater?
A2, sir.
Correct.
A2.
Kepler's second law will says that, and it is even true. It is says that, understanding, whatever the area in a given time period, whatever the area covered by a planet, when it is close to the sun, understanding Ra, in the same given time period, whatever the distance covered by the understanding planet when it is far from the sun, if we'll calculate the areas A1 and A2, then both the areas are equal. Both the areas are what, guys? Both the areas
Equal.
equal. That is what we should call it as Kepler's second law. What we should call it?
Kepler's second law.
Understand what I'm saying? Are you clear, guys? So sometimes planets are close to the sun. Sometimes planets are far
Close to the sun.
far from the sun. So when it is close to the sun or far from the sun doesn't matter. In a given interval of time, what is that? In a given interval of time. Understand, guys? So each planet revolves around the sun in such a way that the line joining the planet to the sun sweeps over equal areas in equal interval of time. Sweeps over equal areas in equal interval of time. Understand, Elamokil, Tamil Selvan, everybody? So,
Yes, sir.
if we'll consider in a given equal interval of time, it doesn't matter whether it is close to the sun or away from the sun. It will sweep how much, Ramaitre? Equal area in equal interval of time. That is what you have to understand. Understand, guys? So I can
Yes,
say
sir.
A2, A1 is equals to what? The area covered when it is close to the sun. From A to A, understanding from A to B, the area of this total, which is equals to what? From A dash to B dash, both are equal. Understand, guys?
Yes, sir.
Yes, that is what you have to understand. That is what it is say. Kepler's second law. What did it say? Kepler's second
Law.
area which is covered when it is close to the sun, understanding, which is equals to the area covered by the planets when it is far from the sun. When it is same interval of time. What is that? Same interval of time. That is what. Okay, guys, please respond me.
Sir.
So now the center of the earth we can assume as center of the sun, we can assume as C. You can assume center, from the center of the sun. Okay, guys?
Yes, sir.
Okay, that is the Kepler's second law. Any doubt, Elamokil?
No, sir.
Darun, Maitreyan, Sai, this is what you have to. Okay, clear? All of you? So planet P, when it is traveling, write the second law, Kepler's second law. Each planet revolves around the sun in such a way that each planet revolves around the sun in such a way that the line joining the planet, the line joining the planet to the Humra Elamakil Tamil Selvan, joining the planet to the sun. Planet to the sun sweeps over equal areas in what? In equal interval of time. Okay, guys? In equal interval of time. That is what we should call it as. What we should call Kepler's second law of planetary motion. Understand the road? Called as Kepler's second law of motion.
Called Brown.
Yes, right. That is okay. So now try to understand very carefully. Here, moves around the sun in elliptical orbit. The planets moves around an elliptical orbit with the sun at one of its focus. That is what we know. Yes, Monish, Maitreyan, Sai. Now, the line joining the planet to the sun, if you'll observe, when it is close to the sun or away from the sun, anywhere, wherever you want, in a given equal interval of time, Understand, Ra? It will covers equal areas. It will sweeps over an equal areas in equal interval of time. So means in the sense of the planet, you have to understand very closely. From that, you have to understand very closely. A planet moves faster when it is closer to the sun and moves slowly when it is further from the sun. Understand, guys? Do you understand, Ra? Please respond. So, when the planet is close to the sun, what is happening? What is happening? Planet moves faster. Understand? Planets moves faster, and when it is far from the sun, planet moves closer.
Lower.
But you remember, Kepler's second law tells understanding that the planet does not move with constant speed around the sun. The speed is greater when the planet is near the sun, and the speed is less when the planet is further away
from the sun.
That is happening because of gravitational force. When the body is very close, observe very carefully, close to the sun, then gravitational force exerting on it is more, so that much faster it will revolve. Understand, guys? Okay, Ra?
Yes, sir.
Yes, but you observe, suppose if the planet, it is not an, sorry, if the shape of the object, the path is not an ellipse, if it is a true circle, then how the speed, how the speed, constant speed or constant speed or variable speed? Constant speed. Understanding? Because the planets move around the sun with a constant speed only when the orbit will become true circle, not an ellipse. Understand, Ra? But unfortunately, an ellipse or circle, ellipse. Understanding? So sometimes the speed is over, sometimes the speed is less, decreasing and increasing. When the speed is more, Tamil Selvan, speed is more when the planet is close to the sun. Understand, Sai? And when speed is less, yes, speed is less when the planet is away from the sun. Please, all of you write it. The planets moves faster. The planets moves faster. The planets moves faster. Are you writing, Laksha, Jayvarshini? Right. The planets moves faster when it is closer to the sun. When it is closer to the sun. When it is closer to the sun, and moves slowly when it is. Darun, are you writing? Tamil Selvan, respond me. Mamanesh, you also, Maitreyan. When it is, and it moves slowly when it is further from the sun. Further from the sun. Understand, guys? A planet moves faster when it is closer to the sun, and moves slowly when it is further from the sun. Understand, Tamil Selvan? Darun?
Yes, sir.
Yes. So now, you observe very carefully. Understanding here the point. For example, in the picture only you can take. So here, what is the area? Can you able to say? This is the triangle shape. What is the triangle here? ABC. What is this?
ABC.
Whatever it is. So ACB is the triangle. So the area of this ACB, which is equals to what, guys? Area of A dash. A dash, C, B dash. That is what we say. Understanding Kepler's second law of planetary motion. Now, if this is happening, why? Because of why the here where the planet speed is more. Now you tell me, in this or in this? Where it is the planet speed is more?
ACB.
Here, planet speed. Understanding? Here, planet moves faster. Planet moves faster, so it will cover what? Large distance. Is it yes or no?
Large distance.
Moves faster.
Yes, sir.
Large distance. Here,
Large
slower, so that it will cover what? Less distance. Understanding, Ra? But the area between them, if you join them, the line joining from the planet to the center of the sun, so this area is equal to what? This area. Understand, Ra? But here distance covered is what? Distance covered is what? More. Here distance covered is what? Distance covered is what? Less. Here distance covered is less because of slowly body is moving. Here distance covered is more. You yourself you can check it. Is it true or not? Here distance covered is more, so that Understanding, but still the areas, if you calculate them, the covered area, both are equal. Understand, Ra?
Yes, sir.
That
Yes,
is
sir.
what you have to remember. So what is this called as? What is this called as? Kepler's second law.
Kepler's second law of planetary motion.
Ah,
Planetary motion.
very, 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 very important one. Understand, Sai, Maitrayan, Tamil Selvan? Clear? Any doubt?
Clear, sir.
Yes, sir.
Now, when the body, now you can see, I am saying the planet is moving here faster and here slower. You have written that point. Now, when the planet will move constant speed, if the path, the orbit is become
Circular orbit, sir.
circle,
True circle.
it will become an understanding constant speed. That point also you should write. Right. A planet could move around the sun. A planet could move around the sun. Good morning, Manya and Samya. Too late. A planet could move around the sun. Laksha, today no response. At least in chat you tell me. A planet could move around the sun. A planet could, as we know that is a circular path or elliptical path. You should tell me. Elliptical only.
Elliptical path.
But if it will become true circle, a planet could move around the sun with which speed, Elmokel? With a
Constant
uniform speed. With the uniform speed. Understand? Only if its orbit were, only if its orbits will become what, Jevarshini? Laksha? Orbits will become what? Orbits were
True
a
circle.
true circle.
True circle.
Orbit will become true circle. True circle. Understanding? So it will become uniform. But what is the shape that one? And it is not an ellipse. Understand? Ellipse circle means not an ellipse. Not an ellipse. Then it will become uniform. Uniform motion. Is it okay, guys? Uniform.
Yes, sir.
Sir.
That is, you should remember. So this is what we should call Kepler's
Second law of planetary motion.
Planetary motion.
Okay. Now, last Kepler's third law. Kepler's third law. All of you write. Kepler's third law. Based upon the Kepler's third law, Newton's derived what? The Newton universal law of gravitation. Understand, Ra? Kepler's third law. So with the help of this only, Kepler's not given any theoretical explanation for this. That is why Newton has used this third law for finding inverse square rule, and has been solved and has been found which formula? Universal law of gravitation. Purinjicha. So now, what is this Kepler's third law? Try to understand very carefully. I will say that is the distance. Planet will be there some distance from the sun. Is it yes or no, guys? It is
Yes, sir.
yes or no?
Okay.
The distance we used to assume as what? R. What is the distance? R.
R.
Understand?
R, sir.
So, what is Kepler's third law means? Try to understand very carefully, guys. The cube of the mean distance of the planet. What is that? The cube of the mean distance. The cube of the mean distance of the planet from the sun is directly proportional to the square of the time it takes to move around the sun. What is that, guys? The cube of the mean distance of a planet. What is the mean distance, anybody? What is the mean distance, Ra? R. What is that? Mean distance R. So the cube of the, what is Kepler's third law means? The cube of the mean distance of the planet from whom, Ra? Elamukil? From sun.
Sun and the planet.
Directly proportional to square of the time period. Square of the time it will takes to move around the sun. Understand, guys? It will takes to move around the sun. This is what we can say Kepler's third law. Understand, Ra? The mean distance, the cube of the mean distance of a planet to the sun is directly proportional to the square of the time period. Square of the time period. Understanding, which will take to what? To move around the sun. This is what we should call as, what we should call, Ra? Kepler's third law.
Plus
Now,
third law.
Third law of planetary motion.
remove the proportionality. We have to take some constant. Is it yes or no? So constant.
sir.
Constant.